here. The sulci, the lateral sulcus is here. The central sulcus is really easy to locate in this one because it's color-coded. It's here. Therefore, the precentral gyrus and the postcentral gyrus. Everything ahead of the central sulcus is the frontal lobe. All the stuff back here after the curve is the occipital lobe. On the brains, I like to use the three-finger method to find the parietal. Take your index finger, put it on the post-central gyrus. Everything your three fingers touch afterwards is going to be parietal. Even on the small models, the three-finger method still works. Okay? Put your index finger on the post-central gyrus. Everything your three fingers touch is going to be parietal lobe. Okay? So, frontal, parietal, occipital, temporal. Longitudinal fissure, transverse fissure, central sulcus, lateral sulcus. Questions before we go on? That's an excellent example of how sound travels much better through a solid than it travels through air. That's just a little ball about so big, and what is it doing? It's bouncing on the concrete, and it sounds like it's in the room with us, doesn't it? I mean, don't you want to turn around and make sure there's not a ball bouncing right behind you? And they're doing it in the hallway out there. You can hear them shoot that thing, and then you'll hear that ball. It sounds like it's in the room with us. When we take the brain and we cut it in half, the first thing we actually have to cut is the corpus callosum. It's this right here. There's a little window, a little wall, sort of. If you look at the septum, if you look at the corpus callosum, it kind of looks like a little arc. Do you see the Nike swoosh?
Mm-hmm.
Well, when you turn it right side up, it's an upside down Nike swoosh. That's called the septum pellucidum. A septum is a wall. So this, you've heard of people have their septum pierced, and they've got the thing in their nose, right? That the septum is a wall. Okay, so this is the septum pellucidum. It's a wall. What is it a wall for? If you look on this one, you see how there's an empty space back here? Well, that's what it's the wall for. There's a little film right here. It's a membrane that separates what's called the ventricles, and we'll look at the ventricles in just a minute. Corpus callosum, septum pellucidum. Do you see the eye structure in the center? That's the thalamus. If you have to look really close, see where it says number 47? It's a dot right in the center. It's not very easy to see. Let's look at this one. It's not quite so busy. See the 47? The dot right in the center? When you get a chance to look at these, you'll see there's a dot. That dot, you could call it one of two things. It's either the intermediate mass of the thalamus or massa intermedia. If you choose to call it the intermediate mass, you must say intermediate mass of the thalamus. Or you can say massa intermedia. This little dot in the center. You actually have to slice through that dot thing when you go to separate the two halves of the brain. The hypothalamus is this little duck's bill that kind of hangs down right here. See a little bean? That's the pituitary. The pituitary is attached to the hypothalamus. If we go under the thalamus, we enter the midbrain. Remember when we talked about the brainstem, I said, okay, really the easiest way to locate the structures on the brainstem is find the pons. And do you see that oval right there in the center? That oval on the center is the pons. Behind the pons and above is the midbrain. Behind and above is the midbrain. Behind the pons and below is the medulla. Behind and below is the medulla. Running through the center of the midbrain, do you see that channel? That channel right there is called the cerebral aqueduct. It flows down into this little triangle, you see, this gap. This gap down here is called the fourth ventricle. I'll explain what it means in just a minute. Cerebral aqueduct goes into the fourth ventricle. Our next structure, or rather pretty much last structure, is the cerebellum itself. See the cerebellum. This model doesn't show it very well. If you look at some of the other models, when you cut the cerebellum in half, you'll see a bunch of white little sticks. It looks like a little white bush. And it's called the arbor vitae. I think it's a misnomer. Because what is Arbor Day?
Tree.
Tree. So arbor means what?
Tree.
Tree. It doesn't look like a tree, it looks like a bush. Vitae kind of sounds like what?
Vital.
Like vital. And if something is vital, it's really, really important. It actually means life. So arbor vitae means the tree of life. I think it's more like the bush of life, but it's not really a tree. But anyway, when you cut it open, you look at it, you see a bunch of little white sticks, a bunch of little white branches, and it's called the arbor vitae. Did I skip anything on the brain? Oh, yes, one thing. That's the olfactory bulb. The Q-tip. See the Q-tip? It's the olfactory bulb. And the optic chiasma. It's not chiasma, it's the optic chiasma. What is the name of the Greek letter X? Chi. The Greek letter X is called chi. So the optic chiasma is the what? The X. Look for the X. X marks the spot. There's an X right there. The optic nerves, I'll show you. The optic nerves come together and they cross and then come back out, and so it makes an X. Like that. Optic chiasma. Right underneath the pituitary. Next are the ventricles. Let me separate it back out. Separate it again. We've already seen the fourth ventricle. We've already seen the cerebral aqueduct. Those are all part of the ventricle system. The septum pellucidum. The two halves of the brain I've already made abundantly clear really aren't attached at very many places. They are attached here. But the septum pellucidum, they're not attached. You cut it just right, and you get this little window on this side, this little window on this side. Okay? Because you actually have holes in your brain. And the holes are called the ventricles. And this is a cast of the holes in the brain. Alright? So what's behind that septum pellucidum? A cavity. Just like this is an ice cube tray. This is the ice cube that fits in that tray. Okay? So this is the ice cube. The tray has the cavities. The cubes are a cast of the cavity, right? They take the shape of the cavity. These are the ice cubes. These are the cavities, the cast of the cavities in the brain. So these two big ones are called the lateral ventricles, and they're located here. If I take this brain apart, that's the lateral ventricle. Remember, this thalamus thing is in there too, but there's a gap. It's not completely filling that. There's a space around the top and the side of it. Okay? See a little space? I can stick my finger back up in there. Okay. Well, that space I'm sticking my finger back up in is this little point right here. Okay. So there are two lateral ventricles, one on the right, one on the left. They are collectively referred to as ventricles 1 and 2. It doesn't matter which one is 1, which one is 2, but together they are numbers 1 and 2. These big horn things, if you think about it like a camel with a gigantic rack. Can you see it? Do you see the camel's head? And then imagine this is like a gigantic antler. A really weird twisted antler. Okay. The lateral ventricles are the weird twisted antlers. This weird twisted antler has 3 horns. It has an anterior horn, a posterior horn, and an inferior horn. and the back of the C is the posterior horn. Those probably aren't on your sheets, but add them. Okay. Oh, the dorsal and ventral rootlets from the other model that's not on your sheets either. Add those as well. And now there's like 6 people recording me, so I approve. All right.
Will you say what they are again one more time?
Which what?
The anterior, posterior, we just... Sorry.
Anterior, inferior,
Inferior,
posterior.
Okay.
The head of the camel is the third ventricle. The little pouty lips, that's right there where the hypothalamus would be. And the head of the camel is right here where the thalamus is. Again, this time I know it's kind of hard to think of it this way. But imagine that the thalamus, this is one half of the thalamus, and this is the other half of the thalamus. And it looks like when they go together, they would fit flat together like that, but they don't. When they fit together, there's actually a little gap between them. That little gap between them is the third ventricle, and it kind of looks like a weird little camel's head. Do you see the eye of the camel? If we put the thalamus together, I told you about that massa intermedia thing. I said you actually have to cut it. And so it actually is a connection of the thalamus. It actually has to be cut. And that's what makes the little eye of the camel. That's the third ventricle. The neck of the camel is the cerebral aqueduct. So now if we look at this really closely, this is where the head of the camel would be. There's the eye of the camel, and there's the neck of the camel. And what's down here? What is this called?
The fourth ventricle.
The fourth ventricle. So this part right here is just a cast of, well, not that one, of this right here. This bit, the camel, the neck, and the tail, is just the cast of that. But this is for a normal sized brain. This is a large one, so it doesn't fit.
Okay.
1 and 2. Third, cerebral aqueduct. Questions? You got more than 30 minutes today. I know you're probably pretty beat, but